Hello children, welcome back. Now let us discuss in detail regarding the determination of value of g, that is acceleration due to gravity at different places. So here we go with the determination of value of g. Children, as we know that from Newton's law of gravitation, if you consider any two bodies, there must be acting force of attraction between the two bodies, and the force of attraction between any two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, and mathematically it is written as F is equals to G m1 m2 upon r square, where F is a force of attraction between the two bodies, G is the universal gravitational constant, m1 and m2 are the masses of the two different bodies, and r is the distance of separation between the two bodies. So now let us try to calculate the gravity, acceleration due to gravity. According to Newton's second law, the general formula for force is given as F is equals to ma. Okay, and this ma must be equals to G m1 m2 upon r square. So let us consider that Earth, whose mass is m. Let this be center of the Earth and this be radius of the Earth r. So let us consider a small body of mass m is dropped from certain height, say h, such that this height from which the body is falling is very much lesser as compared to the radius of the Earth. As we know that the radius of the Earth is around 6,400 kilometers and the height from which it is falling is some few meters, maybe say let us suppose 10 meters. So this 10 meters is very less value as compared to the 6,400 kilometers. So h is very much less than r. And the actual value of r here is the distance between the two bodies, center of the Earth and center of the body. The total distance is taken as r, and this is nothing but the distance from here to here r and from distance here to here, that is r plus h. But as h is very much less than r, we can ignore this h and hence we can take r as approximately considered as the value of capital R, where r is the radius of the Earth. So as I have considered the mass of the Earth as m, mass of the body as small m, so substituting all the values, m1 and m2 are the masses of the two different bodies. m1 indicates the mass of the Earth, m2 indicates the mass of the object. So instead of m1, I can replace it with capital M, and m2 I can replace it with small m. So r is nothing but r plus h, hence h is ignored. I can consider instead of r, I can replace it with capital R, radius of the Earth square. Simplifying this m is the mass of the object on which it is falling freely. So m, force on the body of mass m, F is equals to ma, same body mass m. Hence we can conclude that the value of a as g m by r square. The value of a is g m by r square. But with what acceleration is the body falling down? The acceleration with which the body falls down is due to the force due to gravity, and hence it is taken as acceleration due to gravity, indicated with the letter g. Hence the value of a is replaced with the letter g. Therefore the value of g is equals to g m by r square. So acceleration due to gravity on the surface of the Earth is taken as g m by r square, where g is the acceleration due to gravity, capital G universal gravitational constant, m mass of the body Earth, here r is the radius of the Earth. Not only this, children, the same formula can be applied anywhere. If suppose in place of Earth, if you consider one more body, say moon or sun or anything else. So for example, if I consider here moon, and on which some object is falling of mass m from height h and radius of the moon is taken as capital R. Same formula is applicable. Similarly, if sun of mass m is taken, radius of the sun is taken as R, object on which the allowed to fall is small m from distance h, the same formula is applicable for everything. So let us try to calculate the value of acceleration due to gravity at different places. So one on the surface of the earth, another on the surface of the moon, and then let us compare the both. So first of all, determination of the value of acceleration due to gravity on the surface of the earth, on the surface of the earth. So how to calculate this? We know one and only one formula, that is G is equals to Gm by R square. If you want to calculate this value on the surface of the earth, let us indicate with Ge. So where value of G is universal gravitational constant and its value is 6.67 into 10 power minus 11 Newton meter square per kg square. The value of mass, here mass of the earth, children, remember that the mass of the earth is 6 into 10 power 24 kg. Remember the mass of the earth as 6 into 10 power 24 kg, whereas the radius of the earth is 6,400 kilometers. So these are the generalized values, children. G in capital G indicates the universal gravitational constant whose value is always constant throughout the universe and its value is 6.67 into 10 power minus 11 Newton meter square per kg square. The mass of the earth is approximately 6 into 10 power 24 kg, whereas the radius of the earth is 6,400 kilometers. All are in SI system and this is in kilometers. So let us convert the same in meters. Then this will become 6,400 into 1000 or 10 power 3 meters. These two zeros and these three. Hence, this can also be taken as 64 into 10 power 5 meters. So, radius of the earth is 64 into 10 power 10 power 5 meters. Mass is 6 into 10 power 24 and the value of G is 6.67 into 10 power minus 11 Newton meter square per kg square. So, substituting all the values, we have, let us calculate the acceleration due to gravity on the surface of the moon. Value of G 6.67 into 10 power minus 11. Value of M 6 into 10 power 24 kg. Value of R 64 into 10 power 5 meters. R square indicates 64 into 10 power 5 whole square. Simplifying further, this value is Ge is equals to 6.67 into 6. How much is that, children? So, let us multiply 6.67 into 6. 4002, something like this. So, 40.02 into 10 power, this value minus 11 and 24 will be something like 13 upon 64 square. So, this is equals to 64 into 64 into 10 power 5 into 10 power 5. Let us take it as 10 power 10. 10 power 5 into 10 power 5 is 10 power 10. Or the value of acceleration due to gravity on the surface of the earth is nothing but 40.02 multiplied by, if you bring this 10 upwards, 10 power 13 minus 10 power 10 into 10 power minus 10 will be 10 power 3 whole upon 64 into 64 is 4096, isn't it? So, 64 square is 4096. And multiplying here, we have the value of Ge as 40020 upon 4096. This is approximately approximately equals to 10 times, children. If you multiply 4096 into 10, you will be getting 40960, which is slightly greater than this 40020. And this further simplification will give you the acceleration due to gravity on the surface of the earth is approximately, you are getting it as 9.8 meter per second square. So how much is the acceleration due to gravity on the surface of the earth? It is found to be approximately 9.8 meter per second square. Just go through the simplification, you'll be getting like 9.76 or something. And if you round it off, you'll be getting it as 9.8 meter per second square. Okay, so this is all about the acceleration due to gravity on the surface of the earth. Now let us also try to find out the acceleration due to gravity on the surface of the moon. So next case is all about the acceleration due to gravity on the surface of the moon. Again, let us consider the same old formula. What is the formula, children? G is equals to Gm by r square. Now you want to find out the acceleration due to gravity on the surface of the moon, where the values for G is universal gravitational constant is always constant, whose value is taken as 6.67 into 10 power minus 11 Newton meter square per kg square. Mass of the moon is something around 1.74 into 10 power 22 kg, children. Not like this, something 7.4 into 10 power 22 kg. Well, the radius of the moon is found to be approximately 1740 kilometers, and this can also be written as 1740 into 10 power 3 meters or 174 into 10 power 4 meters. So, taking all the values and substituting in the above equation, so let us try to find out the value of acceleration due to gravity on the surface of the moon. So, the value of Gm is equals to G, replace it with 6.67 into 10 power minus 11. M is 7.4 into 10 power 22 kg upon this radius is 174 into 10 power 4 whole square. Solving this, we have Gm is equals to 6.67 into 7.4. Let us calculate here. 6.67 into 7.4. You'll be getting it as something around, yeah. So this is found to be 49.358 into 10 power minus 11 and 10 plus 22, will be getting it as 10 power 11 upon 174 times of into 174. Square is 174 into 174 into 10 power 8. Isn't it, children? So now let us try to find out the square of 174. So what is the square of 174? Yes, this is found to be 49.358 upon 30276, and 10 power 8, if it is carried upwards, it will be equals to 11 minus 8 is 3. So, into 10 power 3, and further simplification gives 49358 upon 30276. If you divide this, it will be 1 point something, children, and the further simplification gives that the value of moon after simplification you'll be getting something like 1.63 meter per second square. Just simplify this, children, it will be something around 1.6 times, 1.63 times. So therefore, the value of acceleration due to gravity on the surface of the moon is found to be 1.63 meter per second square approximately. So earlier we found the value of acceleration due to gravity on the surface of the earth as 9.8 meter per second square, whereas on the surface of the moon it was found to be 1.63 meter per second square. Now let us compare the acceleration due to gravity on the surface of the earth with respect to the surface of the moon. Taking all the values in consideration, how much was we found the value of acceleration due to relation between acceleration due to gravity on the surface of the earth and acceleration due to gravity on the surface of the moon. As we know, the value of acceleration due to gravity on the surface of the moon approximately was found to be 9.8 meter per second square, whereas the value on acceleration due to gravity on the surface of the moon was approximately found to be 1.63 meter per second square. Equation 1 and equation 2. Okay. So let us divide equation 2 with equation 1. Then we'll be getting it as Gm upon Ge, and this is equals to 1.63 upon 9.8, and this is equals to 163 upon 98. Is that clear, children? 980. 163 upon 980. So simplifying further, this will be, let us so say, children, 163 multiplied by 6 is something like 978, and here you are getting it as 980. So something, so if you simplify this, you will be approximately getting it as 1 by 6. So 163 goes 980 by something like 6 times. Okay, 6.0 something you will be getting. So approximately 1 by 6 times. Therefore, we found that the value of Gm by Ge as 1 by 6. If Gm by Ge is 1 by 6, then Gm will be equals to bringing the G here. So it will be 1 by 6 times of the acceleration due to gravity on the surface of the earth. So what is the relation between the acceleration due to gravity on the surface of the moon with respect to the surface of the earth? Acceleration due to gravity on the surface of the moon is approximately, is around 1 by 6 times of the acceleration due to gravity on the surface of the earth. So this is also you need to remember, children. Okay. So practice well, children.